In this video tutorial, the case structure will be explained. The case is used to enable selection between two or more block of operations. To demonstrate the case structure, a VI will be created that will display the input temperature either in Celsius or Fahrenheit. Within the block diagram, we need to get the case structure. By default, a case structure is Boolean, namely it has two windows, the true and the false windows. These windows are selected by the case selector that will be controlled by a Boolean control function such as a switch. In the front panel, the GUI will have a number control to input the temperature, a switch to select conversion from Celsius to Fahrenheit or Fahrenheit to Celsius, and a thermometer to display the converted temperature. This is the final look of the GUI for the front panel. Here the user will input the temperature, and within this slide switch, the user will select the conversion from C to F or from F to C, and the converted temperature will be displayed on this thermometer, plus in addition there is a digital display to display the temperature. Now in the block diagram, the first thing we need to do is to connect this Boolean switch into the case selector. Now when the switch gives a true value, the true window is selected, and when the value is false, the false window is selected. Now within the true window of the case structure, we need to get the input temperature and convert it into, let's say, from Celsius to Fahrenheit. Once the conversion code has been constructed, now we need to take the output of this add function and connect it to the output temperature function for the thermometer indicator. Note here the tunnel at the output of the case is not filled, implying that within the false window, if we go to the false window here, still the tunnel has not been connected. So if we check here the list of errors, it says here missing assignment to tunnel, which means that within the false window this tunnel has not been connected yet, and it should be connected. In the false window of the case structure, we need to write the code or construct the code required for the conversion from Fahrenheit to Celsius. Notice now the tunnel here is being filled and the error disappears. Now we need to put the code within a while loop, which is controlled by a switch. Running the code now, and we observe that the input temperature is 22, and the switch implies that the temperature is in Celsius. So now we want to convert from C to F, and you can see the output temperature on the thermometer, and on the digital meter it reads 71.6. Now if we flip the switch so that we convert from F to C, and let's say that the temperature in Fahrenheit is, let's say, 80 Fahrenheit. Now we observe that the converted temperature in Celsius is 26.6 Celsius. The case structure can be non-Boolean, namely have more than two windows. To demonstrate this, I'll develop a VI that will either add, subtract, multiply, or divide two input numbers. We can make the case non-Boolean by adding user-defined windows. In our example, we want to add 4 windows. So to add the add window, we come to this button here, which allows me to browse through the case window. So we go to the last window, which is the false case, and here we right click, add case after. We name the case as add, and we repeat this with the other windows, so we right click here, add case after, and this one is subtract. Once we've added all the windows, we should have 4 windows: the add, subtract, multiply, and divide. We now need to remove the default windows, the true and the false. So to remove this true window, right click, delete this case. And also for the false, right click, delete this case. Now we have 4 windows. If we browse through them: add, subtract, multiply, and divide. To select the windows of our case, we need to use a enumerated control, which is an input object having user-defined finite values. Within the front panel, we want to get the enumerated control. Right click, modern, ring, and enum, and here we select the enum object. Now we need to add 4 items to our enumerator object. Now these 4 items would be the add, subtract, multiply, and divide, and they must correspond to the same names given to the case windows. So to add the first item, right click, add item after, and also the second item, which is subtract, and we do this with the other items. Once we've added the items, we can check the values by clicking on the enum object. So when you click, you can see we have now by default this add value has been selected. We also have the subtract, multiply, and divide. Notice here we have by default the empty item, so we need to remove this. So right click, remove item. Now we have 4 items in the enum object which correspond to the 4 windows of the case structure. Now the next thing is to connect the enum function into the case selector. Now in each window of the case structure, we need to add the arithmetic function. So in the add window, we'll add the add function, and we'll connect the first number to the input, the first input of the add function, the second number to the input of the add function, and the output of the add function will be connected to the result. We repeat this with the other windows. Checking all the windows, we see that in the add window we have the code, and the subtract window, the multiply window, and the divide window. Now within the front panel, we run the code and we observe that the first number is 8 and the second number is 3, and the arithmetic chosen is add and the result is given. If we change the arithmetic, let's say to subtract, we get the answer. We choose multiply, we get the answer, and finally we choose divide and the result is given. This concludes this video tutorial.